Good morning, everyone. I hope I'm audible. I'm audible, right? Just mention in the chat box whether you can hear me. Okay. Yeah, good morning, Benson. Good morning, everyone. Okay, so let us start. Okay, so not last class actually, yesterday I gave you the materials. I hope everyone has got. Okay, the materials of the last class and also the one that I have told you to study. Okay, self study. So there one part I missed out. That one I need to do it before starting the treatment part. Okay, so let me share my screen. Just wait. Okay, so this part, this pumps, about pumps. Okay, so pumps, we don't need to go in details, much details about pumps in your this course. Okay, just we need to know why the pumps are required for lifting the sewage. Okay, so that part I missed that day. Okay, so generally, that sewage, that sewage, it is to be lifted from a lower level to a higher level. Okay, so with the help of what? With the help of a pump. Pump, everyone knows why pump is used. It is used to lift something. Okay, so the pumps, the those are used for lifting the sewage. They are used for or used under different circumstances. Okay, there are different circumstances. So what are the circumstances needed for a pump? Okay, so number one is written here is that the sewage from localized low-lying pockets in a city has to be pumped so as to throw it up into the city's sewer pipes flowing under gravity and running at higher elevation. So here the sewage that is present in a low lying city. Okay, that has to be the sewage from the low lying cities. It has to be pumped with the help of a pump. Okay, and it needs to be throw under gravity. Okay, under gravity, and then that are at a higher elevation. Okay, so number two is what you see when the area is flat. Okay, so when the area is flat, the laying of sewers at their designed gradients may involve what? Deeper and deeper excavations in the forward direction of flow. So whenever a area that is it is flat, so when you need to lay the sewers, if you have self studied the laying of sewers, then you will know that when the sewers that has to be laid, they involve some deep excavations. Okay, they involve deep excavations in the forward direction. Okay, so in that type of situations, okay, it is said to be, or it is advisable to lift the sewage at suitable intervals. Okay, so that you can lay the sewer at reasonable depth. Okay, so below the ground surface. Okay, so here you can just see the diagrams that it is the just they are showing the ordinary laying of sewer lines, how the sewers are laid. You can see these are like at a certain gradient they are laying. Okay, from the ground level. So those are excavations. You can see the depth of excavations are they are varied. Okay, they are here it is less, then here it is little bit more, here it is again more. Okay, so these are the depth of excavations. Okay, so next is your okay, third point is your when you there are basements of like for big commercial buildings. Okay, there are basements of commercial buildings. So when you need to dispose the sewage of those commercial buildings, like from the basements, so you have to be you have to pump the sewage. Okay, so that you can pump the sewage from the basement to the street sewer. Okay, to the street sewer, and the street sewers are at a higher level than your basement. So you need to pump the sewage from the basement floor. Okay, so number four is your like when the outfall sewer. So from the outfall sewer is what, like the last ending of the pipe. Okay, from where the sewage it comes out. Okay, from the outfall sewer, the sewage is thrown. Okay, so when the outfall, the outfall part of the sewer, it is at a lower level, and the level of the treatment plant, it is at a higher level. So in that case, the sewage, it needs to be pumped up. Okay, so number last one is your when a sewer, it needs to, it is constructed across a ridge. Okay, it is constructed across a high ridge. So instead of you driving the driving a tunnel, okay, through the ridge, it can be more economical if you pump the sewage into the sewers, okay, across the ridge. Okay, so these are the five circumstances. When a sewer needs to be sorry, when a pump needs to be used for pumping the sewage. So regarding the types of pumps, there are three types of pumps you can see here. Number one is your centrifugal pump, number two is your reciprocating pump, and number three is your pneumatic ejectors or your air pressure pumps. Okay, you just need to remember the names. Okay, so so this is all about your pumps, regarding your pumps. So now let me come to the treatment uh, chapter. Okay, so this is your, just wait. Okay, so this is about your. We are going to start about your treatment of sewage. Okay, so the sewage. Okay, before they are being disposed of into the river, streams, or land, as I already told in the previous classes, these sewages, they are need to be treated. Okay, so that the river water or the land, it is not being polluted. Okay, so the how much treatment it is needed to give to a sewage, or you can say the degree of treatment, okay, that is required for to give to the sewage, it depends upon the what, it all depends upon the characteristics of the source. Okay, it depends upon the characteristics of the source of disposal. So for your sewage treatment, they are classified into your four types of treatment. Okay, so number one is your preliminary treatment. Okay, so the preliminary treatment, what it does, it is defined. Okay, it is defined to separate, the only the floating materials. Okay, the preliminary treatment, it what it does, it separates the floating materials, like what, like you can say that there in the sewage, there are many, floating materials can be there. Okay, like dead animals, the branches of trees, like woods, papers. So all these things, they, in preliminary treatment, it is being separated. Okay, and also what, and also the heavy settleable inorganic solids. Okay, so it also, removes the, oils, greases, all these things from the sewage. Okay, and this is said that this preliminary treatment, it is, it reduces the BOD of the wastewater by about what, 15 to 30%. Okay, so this process, okay, in the preliminary treatment, there are certain, processes or methods you can say. Those are like your screening process. So screening, what it does, it removes the papers, no, clothes, all the suspended materials, you can say, it removes. Then comes your grit chambers. So grit chambers, or you can say detritus tanks, they are removed, they remove the grit and sand. Okay, grit chambers, they remove the grits and sand. Okay, and one more is there is your skimming tank. Okay, all these things we will come in brief in your coming these chapters. Okay, so one is a skimming tank. So skimming tank, what it does, it removes the oils and greases. So you have to remember the name, like which tank or which thing it removes your like oils or greases, or which thing it removes your sands or debris. So all these things you have to know the names. Okay, so we will be discussing about this. So next comes your, after your the floating materials are being removed. So the second treatment is your primary treatment. Okay, so primary treatment, what it does, it removes the large suspended organic solids. Okay, so it is generally the primary treatment. It is generally done by your sedimentation process. Okay, and the sedimentation, it is done in a settling basin. Okay, so like the liquid, the liquid effluent or the liquid sewage, from the primary treatment. Okay, it contains what, it contains a high BOD, you can say. And the high BOD, it is about 60% of the original. Okay, and sometimes you can also say that the preliminary as well as the primary treatment, both this preliminary and primary, they are together, it comes under what, primary treatment. Okay, both the preliminary and primary, because their working is somewhat similar, because they both separate the floating materials, or you can say the large suspended organic solids. So both these treatments, they come under your primary treatment. Okay, so next is your secondary treatment. Okay, so what is a secondary treatment? Secondary treatment, it involves the further treatment of the effluent. Okay, so after primary treatment is done, after preliminary, then primary, then after primary, it involves the further treatment of the effluent that comes from the primary treatment, or you can say the primary sedimentation tank. Okay, so, and this is done, or you can say that the secondary treatment, it is generally accomplished by what? By the biological decomposition of organic matter. Okay, so the secondary treatment, it is generally accomplished by what? Biological decomposition of what? Organic matter. Okay, so which it can be carried out either by, you can say, aerobic or anaerobic conditions. Okay, so this one in this biological units, you can say, in this biological units, your bacteria, it will decompose the fine organic matter. Okay, so when it decomposes the fine organic matter, so what will happen, it will produce a clearer effluent. Okay, so again you can say that this the treatment reactors, okay, in which this organic matter, it is decomposed, it is by done by aerobic bacteria, and it is known as your aerobic biological units. Okay, and also it consists of, in your secondary treatment, it consists of what? Filters also, you can the other name you will get as the name as your intermittent sand filters, or you can say trickling filters. So we will all discuss this later. Okay, so next is your like oxidation cones will be there, aerated lagoons will be there. So all these things will be there, we will discuss. Okay, now you will not understand. So again, you can one more important point is that the effluent from the secondary biological treatment,
Logical
it will
treatment, it will
okay, okay. So it will contain a very small BOD. Okay. So what percentage of BOD is there in your secondary treatment? It is 5 to 10%. Okay. So next comes your the complete final treatment. Okay, so in this the final treatment, or also it is known as your advanced treatment. So what it is done here, it is also sometimes known as your tertiary treatment. Okay, and it consists in removing the organic load left, okay, after the secondary treatment. So after the secondary treatment, whatever organic load is left in the effluent or in the sewage, so that part is removed here. And it also, the final treatment, it also kills the pathogenic bacteria that is present in the sewage sample. Okay, so And this treatment, okay, this like the final treatment, it is carried out by what, by chlorination. Okay. And this this yes, it is done by chlorination, and it is not carried out by what, for disposal of sewage in water. Okay. So so all these things, this four, one, two, three, four, preliminary, primary, secondary, and complete final treatment, this is all about your treatment of sewage. So they are classified, if treatment of sewage, it is classified as your these four things. Okay. So now under this, now under preliminary, under primary, so under all this classification, there are certain methods. Okay. So we will now discuss about this one treatment processes. Okay. So number one is your about this preliminary treatment. We will discuss about the screening process. Okay. So you will discuss about the screening. So screening, we have already discussed, like in your treatment of raw water. Yes. So everybody knows about screening. So what is screening? It is the first process of your, or first stage or step of your treatment process, both for your raw water and also for your treatment of sewage. Okay. So here actually what it is done here, like it is removed. Okay. The screening is screening, it removes what, the suspended organic or the floating materials, you can say it removes the floating materials. Okay. So, like, what will happen if this floating materials, whatever it is, like pieces of cloth or wood or hair, fiber, kitchen refuse, so everything it comes under, like floating materials. So, if it doesn't, like, if it is not removed, so what will happen? It will choke the pipes. Okay, it will choke the pipes, or it can, adversely affect the working of the sewage pumps. Okay. So like uh, the idea for, why the screening is put there, it is, yes, the main thing is to remove the floating materials, the large floating materials, and also so that, it protect the pumps. Okay. And also the other equipments, or you can say from the it also saves the other equipments from the possible damages due to the floating matter of the sewage. Okay. So now this screens, they are, or they should be, they should preferably, you can say it should preferably be placed before the grid chambers. So grid chambers is the next step of after screening. Okay. So you will come to know, so in your raw water that there was sedimentation, yes, so now here after your screening, your grid chamber process is there. Okay. So it is the screens, they are generally placed before the grid chambers. Okay. And there are, you can say, like what are the types of screens. Okay, there are certain types of screens, you see. Okay. So number one is your coarse screen. Okay. The coarse screens, they are also known as racks. Okay. And what is the spacing between the bars? These are 50 mm or more. Okay. And these screens, they do help in removing large floating objects from sewage, and also they will collect about 6 liters of solids per million liter of sewage. So much of, you see, these are core screens, so they collect about 6 liters of solids per million liter of sewage. Okay. So the material that are separated by core screens, they are like already I told that wood, paper, so all these things. Okay. Whatever floating materials are there, they collect it. Okay. And okay, so and what it does, okay, after it separates the like the floating materials, it will not putrefy. Okay. And it will be disposed of by what, incineration or burial or dumping. Okay. So after the materials are being separated, they are disposed of by incineration or burial or dumping. So next one screen is your medium screen. Okay. So the medium screen, the spacing. Okay, so all this the classification or the types of screens, they are generally based on the spacings. Okay, so core screens, from the name itself you can say that the pores, or you can say the bars, they are spaced at a very large spacing. And the medium, it will be a less spacing, and the the next fine screens, it will be more fine. Okay, the pores will be more fine. So in medium screens, the spacing of the bars, it is about what, 6 to 40 millimeter. Okay, so and these screens, it will collect 30 to 90 liters of material per million liter of sewage. Okay, so here 30 to 90. So all this things you know, note it down in your copy later, this important lines. Okay, no need to write everything that is given in the this material. Okay, you just point out some important lines and you can write it in your copy. Okay, so uh, okay, so it collects your 30 to 90 liters of material per million liter of sewage. Okay, and the screenings usually contain some quantity of organic material which may putrefy and become offensive, and it must therefore be disposed of by incineration or burial. And it is here the metro sewage, it is not being dumped. Okay, so next is the diagrams. Okay, I shall show you the diagrams of the screens. You can see this one is a medium screen. Okay, this is a medium screen in the diagram you are seeing. So these are the spacings actually. Wait. So they are telling about this screens or racks. These are, there are certain spacings in between here. Okay, this one rack in between, there are spacings. So they are talking about that. Okay. So next is your okay, they are both, in under your medium screens, there are both your fixed screens and movable screens. Okay, two types of screens are there. So these fixed screens, they are permanently set in a position. Okay, they cannot be moved. And the movable screens, they are stationary during their operating periods, but they can be lifted up. Okay, for purpose of cleaning, if they needs to be cleaned, so they can be lifted up. Okay, and they can remove from the positions, and they can be again put it there. Okay, so there are two types, like fixed and movable screens. So number three is your fine screens. Okay, so the fine screens, it have perforations, you can say, of about 1.5 millimeter to 3 millimeter in size. Okay, and the installation of these screens prove very effective, and they may also remove 20% of the suspended solids from sewage. Okay, and these screens, they gets clogged very often because their perforations are very small. So their chances of getting clogged is very often. Okay, and they need what, frequent cleaning. Okay, because it gets clogged very frequently, so it needs to be cleaned frequently. And they are used only for treating the industrial wastewaters, or you can say for treating those municipal wastewaters. Okay, like which are associated with heavy amounts of industrial wastewaters. Okay, so this is all about your this screens. Okay, this is all about your screens. So what's the time? 9:49. Okay, so after your screening, okay, after your screening, we have, okay, my network got disconnected actually. Okay, Okay, so after your screening process, what we have, let us see. We have the grid chambers or channels. Okay, okay, okay. As after this class, this link gets this one ends. Then you join by 10:15. Okay, 10:15 you join. You take 20 or 15 minutes break. Okay, after that we can join the class. Okay, so next is your about grit removal basins. Okay, or you can say grit chambers or channels. So, like the grit chambers or grit channels, they are usually called what sedimentation basins. Okay, so they are generally done by, or you can say they are usually called the sedimentation basins. Those are placed usually after the fine screens. Okay, just now we have read about the screens. So these grid chambers or grid channels, they are being placed after your fine screens and certainly before the primary sedimentation tank. So after your fine screens and before the primary sedimentation tank. Okay, so the grid chamber, it what it does, what is the work of the grid chambers or channels? The work of the grid chamber, it removes the inorganic grit. Okay, such as what sand, gravel and other mineral matter. Okay, like it removes the sand or gravel, those are present in the sewage. Okay, and the mineral matters that has a nominal diameter of what 0.15 to 0.20 millimeter. Okay, so like this grit, okay, it also includes what smaller mineral particles, okay, that may settle, okay, or they are as well as what non-putrescible organic matter such as like woods and papers, all these things. Okay, and the amount of grit, okay, that is collected, it is a function of what the removal device. Okay, the amount of grit collected is a function of the removal device, then its operation, and what and the quantity of grit in the sewage. Okay, and therefore it varies over a wide range, and the grit quantity, it may vary between 0.04 to 0.037 meter cube per 1000 meter cube of sewage for separate sewage system. So all these values, you have to like note it down, because some values you will be requiring for your numerical purpose. Okay, so you have to remember some of these values. Okay, so the values you need to remember. Okay, okay, so I shall continue from here, from 10:15. Okay, so the reminder has come, like 3 minutes are left. So, okay, join by 10:15. Okay, everyone, join by 10:15. You take a 10 minutes break, 10-20 minutes break.